So inside SQL Server there are two kinds of indexes, clustered and non-clustered. And creating and planning indexes is really not that hard once you understand exactly the flow of how a clustered index and non-clustered index work. So let's talk about clustered indexes first. A clustered index essentially is the order of the data in the table, just like a telephone book, in the same way that a telephone book is in a specific order or a clustered index order. To make the clustered index fast for searches, the clustered index is actually the data pages and a B tree or a balanced tree index married together. So using the telephone book analogy, the B tree would be the first and last name, which would be considered the two key columns, meaning the columns that it is sorted by. And if you open up a telephone book and you're looking for the last name of, say, Nielsen, and you open it up and right in the middle you come to the M's, you'll then know, I have to turn to the right, and you'll turn and you'll continue to just sort of drill in to the N's to find Nielsen. In the same way, the B-tree index allows SQL Server to quickly navigate and sort of split in half to go to the root level of the index, a few intermediate levels depending upon the size of the index, and get right to the leaf level, I'm indicating here, and to get to the entry it's looking for. The leaf level nodes then have the data for the key columns, and attached to them is all of the data pages, all of the other columns that are not a part of the clustered index sort order. As you can imagine, using the clustered index is extremely fast depending upon what you're looking for. And of course, because it's the physical sort order of the data, you can only have one clustered index per table. Usually, the clustered index is assigned to the primary key, but that's not always a hard and fast rule. Let's talk about the benefits of the clustered index, and that will help you determine when to use a clustered index. There are primarily two benefits. The first one is the leaf level row you're looking for, the data page is right there. You don't have to look anyplace else to find it. And you'll see that can be a problem with the non-clustered indexes, and you'll see that in a few minutes. The other advantage of a clustered index is that it will group together a number of rows on the same or a very few number of data pages. Think about it this way. If you were searching in a telephone book for everybody with the exchange of 123, if that happened to be a valid exchange for that city, you would have to scan throughout the entire telephone book, manually looking at every entry, and you would find them scattered throughout the entire telephone book, so you'd have to read in the whole telephone book. But if the telephone book was organized by telephone number, then all of the exchange of 123 would be right together, and those, what would that be, 1,000 entries maximum, might be listed on only 4 pages. So once you found it, you'd only have to do 4-page reads instead of several thousand-page reads. So the ability to group together a number of rows in a few number of pages reduces the amount of reads and improves performance. So with those two key benefits in mind, if you're usually going to be searching for single rows for the purposes of updating or finding a row, and you're usually doing that search by a primary key, then yes, the primary key is excellent as the candidate for clustered index. But if you're usually searching for the data by perhaps one of the foreign keys, and you want to group together all the rows with the same foreign key, then that foreign key might be the best clustered index. An example of this would be clustering an ordered detail table by the order ID, so that all the detail rows for that order are on the same data page. And when you go to retrieve them, they're all very close to each other. The second type of index inside a SQL Server is a non-clustered index. And you can visualize this index like the index in the back of a book. You can quickly find an entry, but then to find out more about that entry, you have to turn into the pages of the book. The same thing happens with a non-clustered index. Using the balanced tree, SQL Server can quickly find a row in the non-clustered index based upon the index keys or the columns that are included in that non-clustered index. But then if it needs to find any information from columns that are not a part of that non-clustered index, it has to then turn back to the data pages and look them up. And this process is called a bookmark lookup. As you can imagine, if you're searching for only 2 or 3 entries, there's no problem looking in the back of the book and then turning into the pages of the book to find the answer. But if you go to one of the index entries in the back of a book and underneath, say, George Washington, there are 200 different pages listed, now you have a tedious process of looking into 200 different pages in that book, which could be very expensive as far as time and resources. Or if you look in the back of the book index and you find multiple entries, say you're looking in a U.S. history book and you want to find out about the life and times of every president, and in the back of the book index, there is a heading called Presidents, and underneath there, every U.S. president listed. Again, you'll have a number of pages to go search, and that can be a slow process. So there is this myth that an index seek is always the fastest way to solve a query. And as you'll see when we start talking about query execution plans, that's not necessarily so. It's quite possible, depending upon the amount of data that you're pulling in, that an index seek would be inefficient. Let's say the book is just simply a book of the life and times of every U.S. president. And if you go back to the index and turn, you'll end up turning to every page. It's going to be much faster to just read the book.